All right, let's try to finish up. Well, continue with. We didn't get that far into 2.5, so hopefully we'll be able to finish it today. So we are on example 3. Now, this is going to take me a minute to graph this. So they start off with a graph. You know how example 2, they gave you the restrictions, right? They gave you the function and the restrictions, and you had to graph it. This time they're going to graph it for you, and guess what they're going to ask you to do? Find all the what? All the restrictions and the equations of the line, all right? So it's kind of the same thing, but it's kind of flipped a little bit. All right, so we got a big old graph right there. So let's fill in everything. I got to graph it. This is probably the hardest part, is just to graph it. So it goes from negative 4, 0, 1, 2, 3, 4. I'm going to write it in there as well. Negative 4, 0, and it goes to negative 2, 2, right there. Oops. But at negative 2, 2, it's open, all right? And there's a line that connects them. There you go. So that's the first part of it. Remember, these are piecewise functions, right? We split it into several different pieces. That's the first piece. Then the next one starts at negative 2, 3. Negative 2, 3. This is closed. And it goes straight across to 0, 3. And that is closed. So we're going to find the equation, basically, of 3 different segments. And this is what? Negative 3, 3, is that what I said? Negative 3, 3. And this right here is 0, 3. Then one more little part of this. This goes to 2, 0. And it's closed here as well. And it goes down to there. All right. It shouldn't be all that hard. And this is at 2, 0. And what we're trying to do is we are trying to find the equation of all 3 of these and where it's restricted. All right? Okay. So I got to find the equation of this little bit right here. Now look, it doesn't go all the way to the y-intercept, does it? Yes, Joel. This is 0, 3, and this is 2, 0. This is negative 3, 3. It sure is. It's not negative 3, 3. It's negative 2, 3. What's wrong with you? You can't read? No, that was my fault. Negative 2, 3, sorry. Negative 2, 3. Thank you. The other one is 2, 0, because it's right on the x-axis. All right. So let's take a look at this one right here. That's what we're trying to find first, trying to find the equation of that line. Normally, we would find the y-intercept, wouldn't we? All right, and then you could count to find the slope. But we don't really know what the y-intercept is because it doesn't go all the way up to the y-intercept. Agreed? So how in the world could we find the equation of this line? Well, you could find the slope. Slope's pretty easy. I can just count, couldn't I? So let's go from here to here. What would I do? I would rise what? So the slope, rise is negative 2. Okay, the direction makes a difference. This would be negative 2, and then we run what? Do we? Negative 2. So what is the slope? It's positive 1, right? It's just 1. Now, the y-intercept. Don't know what the y-intercept is. I mean, maybe I could extend that out to see where it hits, all right? Or I could do it mathematically. Let's do it mathematically. I know the slope, and I know a point, don't I? I know 2 points. I know negative 2, 2, and I know negative 4, 0. So which one do you want to use? Doesn't make any difference. Do you want to use negative 4, 0 or negative 2, 2? Yeah, negative 4, 0 sounds like that might be a little easier because it's got the 0 in there. All right, so I'm going to use the point negative 4, 0. All right, and we'll plug it into this thing and see what we get. So what is the y? 0 equals the slope, which is 1, times x, which is negative 4, plus b. That's a negative 4. We can do a little bit of this in our head, can't we? This is negative 4. Agreed? And then I got to move it over here. So what's b? Positive 4. Doesn't it look like it would hit positive 4? Yeah. Okay, if I extended that out, I'm pretty sure that it would hit right there. And I just kind of guaranteed that it would. All right. So what is the equation of this little slanted line? It's y equals m, which is 1 times x, and then plus 4. So that's my first one. I'll put a little 1 in front of it. You with me on that? But is it just this? No. They're going to say if. Where does x have to be? I can't include every single x for this, because if I included every single x, that line would go all the way down here. It would go all the way up there forever, but it doesn't. It starts here and it ends here. So where is the restrictions for the x? From where to where on the x-axis does this line go? Well, where does it start? What's the smallest x value of this little line segment? Negative 4. And then it keeps going until it gets where? To here. To where? Negative 2. So x has to be between negative 4 and what? Negative 2. But this is a solid line. So what am I going to put here? Less than or equal to. This is an open circle. So what's this going to be? It's just less than. It's not or equal to. So this little bit right here, the negative 2, it's open. So we put just less than. So that's the equation for that piece of the graph. You with me on that? Okay? So that was the hardest one. I'll tell you what, just for what we're doing, I'm going to erase all this just so I can scooch all that stuff up. Is that all right? Okay, so that's the first part of it. Now we got a second part to it. Second part, we'll call this our second part right there. What kind of line is that? It's a horizontal line. So what is a horizontal line? How do I write that? What is it? Y equals, right. Y equals wherever it hits the y-axis. And this one does hit the y-axis. Where does it hit it? At 3. Hits at 3, doesn't it? So this little bit right there is a horizontal line, so it's y equals wherever it goes through the y-axis. Excuse me. So, but we do have restrictions. It doesn't keep on going forever and ever, does it? What's the furthest left? We'll put it if. What's the furthest left on this little part right here? At negative 2. So it starts at negative. Let's scooch this over a little bit. All right, so it starts at negative 2. How far does it go on the x-axis? To 0 on the x-axis. On the x-axis, it goes to 0, doesn't it? I mean, it's way up here at y, or at 3 on the y, or yeah, on the y-axis. But left and right, it goes from, because we're just trying to find the domain, because we're trying to find the restriction of the x. So it's negative 2 to where? To 0. Now, is it less than or equal, or just less than? They're both or equal. Why? Because they're both closed circles. That's right. So this is less than or equal, and this is less than or equal. And that's our restriction for that graph. So that's our second one. That was pretty easy, wasn't it? Since it's just a horizontal line. All right, we got one more to do. It's kind of like number 1, except it's a little bit easier. Why is this one right there a little easier than the first one? Nah, it's not because it has 2 zeros in it. Say that? Well, it's a negative slope, so it's not positive. This is positive. Left to right, you're going up. From left to right, you're going down. So it's a negative slope. But what's the one thing we had to do work on to get this? We had to find the slope, didn't we? Yeah, so you had to find a point. Or, yeah, well, we had to find the slope. We just counted. But then you had to find the y-intercept, right? Then you stuck those things in there. You stuck the slope in there. You stuck a point in there. You had to find the y-intercept. What about this one? Come on. You already know the what? Well, we knew the slope on this one. What did we not know on this one that we can just look at and see this one? The y-intercept. That's right. I can just look at this and I can see the y-intercept. So do I have to really do any work to find that y-intercept? No, I can just look at it and see where it hits the y-axis. On this one, this first one, I mean, I kind of would have guessed it would hit there, but could I just look at it and tell? No. So I had to do a little work to find it. On this one right here, I could tell where it hits the y-axis right there. Everybody with me? So so that means the b, the y-intercept, is what? It's 3. What's the other thing I need to find the equation of this line? The slope. So we could just count. Go from this point to this point. Let's count. 1, 2, 3. That's -3. So the slope is -3 over the run. How far is the run? 1, 2. Positive, and so that's your slope. Can you write an equation of a line with those two things? Absolutely. That's all you need, isn't it? So y equals -3/2 x plus 3. And that's the equation of the line. But you can't just leave it like that, because that line doesn't keep on going forever on the x and the y, or the x direction, negative and positive, okay? It doesn't keep on going forever. What are your restrictions? So we're going to say if x is where? Between what and what? No, x. The x. This is the x direction. We're moving left and right. This graph, left and right, where does it start? It starts at 0 on the x-axis. And how far does it go on the x-axis? It goes to 2. They're both closed, so this is what? Less than or equal, and this is less than or equal. Right? So we're just finding the domain. The domain are the x values. Where are we restricted? On the x-axis. So you're not looking to see how far up you go to find the domain. You're just looking left and right to see how far you go. And that's it. All right? So they give you the graph. You have to come up with the equations, and you have to come up with the domain, or the restrictions. Does that make sense? Yeah, it's the same thing as we did before. This might be a little bit harder, because you really got to know what's going on. If you were given this, right, there's two problems that they could give you like this. They could give you this stuff and you graph it, or they could give you the graph and you got to write all this stuff. Okay? So make sure you can go both ways. All right. If I went too fast, if I skipped something that you didn't really understand, go back, watch the video, pause it, right? Think about it, and hopefully that'll help you out. Does anybody ever do that to the videos? Okay, I hope so. All right. Now, this is the weirdest one. I could almost guarantee you've probably never seen this one. Let's copy that so I can use that again. All right. This is another piecewise function, and it has a special name. It's called a greatest integer function. Greatest integer function. And it's got a little symbol. So if I wanted to find the greatest integer of a certain number, we do it like this. We put it in a bracket, and you can put whatever the number is. All right? I'm just going to put an x. That could represent any number. All right? Now, what in the world does that mean? Well, I'm glad you asked. Here's what it means. The greatest integer function is the greatest integer. You're like, okay, doesn't help, but I got a little bit more. It's the greatest integer less than whatever that value for x is. All right? So for instance, what if I said 3.1 and I put it in that little bracket? That means what is the greatest integer of 3.1? What does that mean? It's the greatest integer that is less than this. What's the largest number, the greatest integer? What's the largest number that is less than 3.1? It's 3. That's right. Now, 2 is less than 3.1, but is that the largest? Is that the greatest integer that's less than 3.1? No. So whatever that is, you're just looking to the left of it. You're finding the integer. You know what integers are, right? -3, -2, -1, 0, 1, 2, 3, ... this way, ... this way. Those are integers. It's a point. I said it. When I wrote it down, I said 0.1, 3.1. What if I had 3.9? What's the greatest integer of 3.9? 3.8 is an integer? It's 3. What's the largest integer number? Not just any number, the integer. What's the biggest integer that is less than 3.9? That would be 3. Well, it could be negative. It could be negative, but these are your integers right here. That's why I wrote those down. Those are your integers. What about this? What if I just said 3? Let me think about that a second. It's not. I got to think about my explanation because my definition . The greatest integer. I put less than x. Is it less than or equal to x? Because the greatest integer of 3 they consider to be 3. But that kind of flies in the face of my little definition right here. It might be or equal to, less than or equal to x, but I don't know. You see the definition in the book? It's on 2.5. I don't have it in front of me, the book. Can anybody see where you first talk about greatest integer function? I want to see what they say as their definition. Maybe I just wrote it down wrong. But anyway, I do know it's this, though. When you just have a whole number, it's whatever that whole number is. All right, so we can just remember it that way. Anybody looking? Gavin, did you find it? The greatest integer function. It does say or equal to. I got to change that in my notes. I was wondering. Thank you for looking that up. I feel better about it now. Instead of just saying less than, what does it say? Less than or equal to. Wow. Or equal to. Less than or equal to x. Okay, good. I feel better now. I'm glad we looked it up. Okay, so it's less than what? Or equal to. Whatever that x is. So would you agree with that? What's the biggest number that is less than or equal to, or not number, what's the greatest integer that is less than or equal to 3? Well, 3 is. Now 2 is less than it, but 3 is bigger, right? And it's or equal to it, so that's that. Okay, enough of that. Let's look to graph something. So what if I was to graph the greatest integer function of x? What I'm going to do, I'm going to start us off. It's going to be a weird graph. It's a graph that you've never, my guess is you've probably never seen it before. All right, so we'll say x and y. I should say y equals. Yeah, or f of x equals is really how they're going to write it. They probably won't use the y here. So f of x. That's a little bit better. And instead of putting y here, I'll put f of x. It kind of means the same thing, but this is how you'll see it. You remember when you first started graphing, you did that little table, and you just threw some numbers in and then plugged it into the formula, right? Got an x and got a y, and then you plot the points and you get a nice straight line, right? We're kind of going to do the same thing here. So let's start off with -3. Now I'm going to jump down a little bit, and I'll show you why in a second. Jump down to -2, jump down to -1, and it's really all we need to do this. So what would the greatest integer of -3 be? It's just -3. What about the numbers in between, though? All right. So we could go, what would the, let's go 1 decimal place. What's the number just below the -3 if we just go 1 decimal place? -2.9, right. So it'd be -2.9. Now, what's the greatest integer value of -2.9? It would be, it's the number that is smaller than this. It's the integer that's smaller than this. Well, you can't do a point. You know a point something's not going to be right because it's got to be the integer. What's the largest integer that's less than or equal to this? -2 is bigger than this. -3, right. I heard a lot of people saying -2. -2 is bigger than this. So what integer number is the next one just less than this? It'd be -3. So when I put a -2.9 in there, what do I get here? -3. What if I put a, I don't know, -2.5 in here? What do I get? -3. What if I put, let's scooch this down a little bit. What if I put a -2.1 in here? I'd still get -3. All the way until I get to -2. When I get to -2, what am I going to put in? A -2. Now, what about all the numbers in between here? They're all going to be -2s, aren't they? Until you get where? To -1, and it's going to be what? -1. You follow what we're doing? All right, we're finding the greatest integer that is less than or equal to that number in my chart, all right? So what is the largest integer that is less than or smaller than -2.9? Well, -3 is. You get it? What if it was like -2.5? What's the biggest number, integer? I keep saying number. What's the greatest integer that is less than -2.5? -2, and everything in between. We get it? Now we have to graph this thing. Once you do that little table, you probably won't have to do that table anymore because you got a general idea of what this graph's going to look like. So let's start here. -3, -3. So I'll just put 1, 2, 3, 1, 2, 3 right there. Oh, -2. I can't count today, can I? I tell you what, let's do this. Since everything's like so close to each other, do you mind if I go like every 2 blocks is 1? Is that all right? So this would be what? -1, this would be -2, and that would be -3. You okay with that? Just to stretch it out a little bit, okay? Because it would be really tiny if I didn't do that. And then every 2, and every 2. You do not. You do not. That's right. You would make a line because these aren't the only numbers in between, are they? You could have -2.9999999, right? You could have -2.9999998. It'd be impossible, wouldn't it, to put all the points in there? So how do we show everything in between there? Just a straight line. Exactly. All right. But I'm going to put the integers there first. So -3, 3. 1, 2, 3. 1, 2, 3. That's my first integer. Now, if I went, let's just say a half, -2.5, then where would I drop down? I'd drop down to that same spot, wouldn't I? Anywhere, right, between -2 and -3 would go where? It'd go all the way until we get where? To -2. Well, watch what I'm going to do. I'm going to put an open circle right there, because that could be -2.1, that could be -2.01, -2.001. I get closer and closer and closer, but I'm never going to hit it until where? Until I go to -2 on the x-axis. Once I go to -2, then where can I go? Now I can have a closed circle at -2. And what do you think that's going to look like? This is going to go all the way until we get to where? It's going to be -2, -2, -2, all the way until we get to -1. All right, but it's going to be open right there. And we got a line in between. See what we're doing? Now what are you going to do? Go to -1, -1. It's going to be closed at first, but then it's going to go all the way until you get to the next integer, and then it's going to be open. You see the pattern? Now we're going to jump up to the next integer, which would be 0. Close it here, go all the way across until we get to the next integer, and open it. Now you're getting the hang of it, right? So jump up to the next one, close it, all the way to the next integer, jump up to the next one, close it, all the way to the next integer, open. You don't have to, I'm just showing you, I'm just trying to fill up the graph so you can see pretty much all of them. Right? If you wanted to, you could come to here, couldn't you? You don't have to do every single one of those, but do enough. Don't just do one of them. I would say at least 4 or 5 of them, all right? But once you get one of them down, the rest just kind of flow, all right? So it's not like it's that hard once you get one of them. Normally, if I was to graph this, normally I would just start right at 0, 0, go here, open, jump up one, close it, go all the way to the next integer, open, jump up one, close it, all the way to the next integer, open it, and so forth, okay? They kind of look like what? Yeah, look like steps, don't they? And they call that a step function. There are other types of step functions, but this is the first one we're going to look at. So a lot of times they call it a step function, but that's what it is. Question? You're whispering. I can't hear anything you're saying. Yeah. All right, yeah, we'll do that in a second. All right, let's just finish up these problems, and then if we have time, we can look at the homework. When's this over? 25? Okay. Yeah, I got to move on. Example 4 is just kind of doing what we did right here. All right, if I give you a decimal and you tell me what the greatest integer of that is. So example 4. It just says evaluate f of x equals this when part A says x equals 2. So really all we're doing is just putting a 2 in for that. So what is the absolute value, or not absolute value, it's the greatest integer function of 2. Remember, if it's a whole number, what do? It'll just be that same number, exactly. All right? So if I asked you what the greatest integer function of 2 is, you would just say 2. That's easy, right? Of course. What if I said x is 3/2? Well, where is 3/2? Let's write it as a decimal or a mixed number. What would it be? 1 point what? What's 3/2? 1.5. Thank you. All right, it's 1.5 or 1.5. All right, so what is the greatest integer function of 1.5? Right, it's the number that it's the integer that is less than or equal, but that's not an integer, so it can't be equal to it. All right, so what's less than 1.5? It's just a 1. You with me? What about this one? What if x was -2/3? So put that in the bracket. What's -2/3 as a decimal? I think that's an easier way to look at it. 0.6. Yeah, there's the negative. 0.6 repeating, right, okay? So you just want to put 1 in there, put a 0.67. Really doesn't make any difference, okay? So what's the integer number that's less than, what's the largest integer that's less than negative 0.67? If you get confused, do this. There's 0, there's negative 1. Where's negative 0.67? It's right there. So what integer is to the left of that? It's negative 1. You see that? That number line can help sometimes if you get confused, especially with the negatives. When it's positive, it's not that tough. But if it's... And then they just do one more. I don't know why they did this, but they did. So I'll put it on here. What if x was negative 5? What's that going to be? It's just negative 5, right. If it's an integer, it's just whatever that number is. You got it? Okay. So that was pretty easy. All right. Let's go to another type of function. Remember, the title of this lesson was Special Functions. So that was pretty special, right? You've done... Now, on this one right here, I think we did this in geometry, I think. Absolute value. Did we do this in geometry? I think we might have. But if not, that's fine. We'll do it right now. You know what absolute value is, right? So what's the absolute value? Now this is different than a greatest integer function. This is the absolute value symbol. It's not a bracket, it's just two vertical lines. What's the absolute value of negative 3? What's the absolute value of positive 3? It's 3. Absolute value just means your answer is always going to be positive. So what if I said this? What if I asked you to graph f of x equals the absolute value of x? Or y equals the absolute value of x? If you're not really sure, let's start with a little table just to get us going a little bit, all right? Put y, should have put f of x. Yeah, let's go, I don't know, like negative 2, negative 1, 0, 1, 2. Is that all right? All right, so if I put a negative 2 in for x, I'm taking the absolute value, negative 2. What is that? It's 2. Absolute value, negative 1, 1. Absolute value, 0, 0, 1, 2. You with me? So what I'm going to do is I'm going to plot these points. So I'm going to plot negative 2, 2. Tell you what, I'll just go back to each block being worth 1. Is that all right? So I'm going to go negative 2, 2, right there. Negative 1, 1. 0, 0, 1, 1, 2, 2. And you could keep on going, couldn't you? 3, 3, 4, 4, 5, 5, and so forth. All right, I'll just do a few more. There's negative, what, 4, or negative 3, 3, negative 4, 4. What's it kind of looking like? Like a V, doesn't it? So that would go that way. And then this would go, oops, start here. So go this way. There we go. So that right there, and it keeps on going. That right there is an absolute value function. Pretty simple, isn't it? It's like a V. So if it was just f of x equals x or y equals x, it would just be a line that goes like this and keep going like that. But when you put a negative into an absolute value, you're always going to get a positive answer. That's why this graph doesn't keep on going like this. You're not going to have any negative y's because the absolute value is always going to make it positive. All right? Oh, I still don't think we're going to completely get done, but we're going to get really close. Let's just get rid of this stuff right now. Let me show you something that's kind of interesting. What if I had something like this? This is example 5. I'll keep that red one right there just as a reference graph. Okay, that's my regular y equals absolute value of x. What if I asked you to do this? I keep saying y, but you could put f of x or g of x, right? It's the same thing. F of x, g of x. Doesn't matter what letter you use. But what if I did this? The absolute value of x plus 3. Let's do that in a different color. We'll do that in yellow. What would that do to my graph? Let's use those same points that we did before, right? -2, -1, 0, 1, 2. Is that all right? This is x, and this is my g of x. Right? So when it was just regular absolute value, I put it in here and I got a 2, right? So -2, 2. But now what do I have to do with each one of these? I just got to add a 3. So it would be what? 2 plus 3, which would be 5. Put a -1 in there. That makes it +1 plus 3 is 4. Put a 0 in for this. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. You with me? So watch what it's going to look like. -2, 5. -2, 1, 2, 3, 4, 5. Point right there. -1, 4 would be there. 0, 3 would be there. 1, 4, 2, 5. So what's really the only difference on this graph? What's it doing? Yeah, it starts 3 higher. That's right. We just took that red graph, and what did we do to it? We just pushed it up 3 places, didn't we? So what happens when you take an absolute value and you add something to it outside the absolute value? What happens to it? It pushes it up. What if it was absolute value of x minus 3? What do you think it would do? That's right. So it would start here at -3, and it would just still be that same v, right? But it would go starting at -3. Make sense? Let's do one more of these and we'll quit. Don't pack up yet. I can hear it already. What if you had, they call this h of x to make it different than this g of x. What if you had this? And we'll do this in a different color. Let's do this in blue. What do you think that does to it? It may do something different than you think it's going to do. Let's put those same numbers in. -2, -1, 0, 1, 2. All right, let's put them in. Put it in -2 for this. -2 minus 2 is -4. What's the absolute value of -4? It's 4. Put in a -1. -1, the bell's going to ring in a second. Hang on, let's finish this problem, then you can go, okay? -1 minus 2 is -3. Absolute value is 3. Put a 0. Absolute value of -2 is 2. Put a 1 minus 2 is -1. Absolute value is a 1. Put a 2 in for this. 2 minus 2 is what? 0, right? And, oops. Yeah, put a 2 in for this. 2 minus 2 is 0. Let's keep doing a couple more. Put a 3 in there. Hold on. 3 minus 2 is 1. 4 minus 2 is 2. And you get the idea. So watch what happens. Everybody watch. -2, 4. 1, 2, 1, 2, 3, 4. Is that 4? Did I count right? Okay. -1, 3. 0, 2. 1, 1. 2, 0. 3, 1. 4, 2. You see what's happening? Look what it did. What did it do? It made a V, but it's off, but look which way it moved. It moved, originally, this was our graph, right? It moved from 0 where? To 2 on the x-axis, but it moved to the what? To the right. So look at this. So that's a little bit different. You may think that it may move it to the left. It doesn't move it to the left. What does that minus do? It moves it to the right. What if it said, last thing, what if it said absolute value of x plus 2? Where do you think that's going to move it? It's going to move it to the, no, this one moved it to the right. What's this one going to go? This one's going to go to the left, right? And then it's going to look like the same graph, except we shifted it to the left. Now, you should be able to do most of these. I only missed one example, so let me assign the homework. Oh, I don't have it on my paper. I do have it on the, what is it? 7 to 28. All right, let me see. Page 85 and 86. Pages 85 and 86, number 7 to 28. You should be able to do most of those. There may be a couple at the end that we didn't hit. You should be able to do most of those.